All right, test review part B. Why does the table represent a linear or nonlinear function? So first let's decide if it is linear or nonlinear, and let's look at how the x's and the y's change. So when we start, we notice that the x's change by adding 2 each time. Adding 2, adding 2. So my change in x, that little triangle means change. My change in x is I'm adding 2 each time. All right, my change in y, I'm adding 4 from 0 to 4. From 4 to 8, I'm adding 4 more, and from 8 to 12, I'm adding 4 more. So my change of y, I'm adding 4 each time. So this is called our rate of change. Our rate of change is found by doing our change in y over our change in x. And every time we did it, it was a 4 over 2, a 4 over 2, a 4 over 2. So all of our rates of change, were 4 over 2, 4 over 2, and 4 over 2. So it is linear, so it could be answer choice A or B. But the reason, A says linear because the x values are going up by 2 each time. And that's not quite right. I mean, it's true. The x's are going up by 2 each time, but the fact that the y values are also changing at a constant rate is important as well. So the x's and y's are changing by a constant rate or a constant value. That's why B is correct. So A didn't give us enough information. A just talked about the x values. B talked about the x and y values changing at that constant rate. So that's an example of a linear function. Okay, a nonlinear function would be slightly different. It would be x and y, and maybe the x's change at a constant rate, change by 2's, but then the y's, maybe we have 0 to 4, and then maybe from 4 it's 4 to 7, and then from 7 maybe it's 7 to 9. So the rate of change of the x's is still 2, but the rate of change of the y's is different every time. That's adding by 4, that's adding by 3, that's adding by 2. So the 4 over 2, the 3 over 2, the 2, they're different. So this would be an example of a nonlinear function. Okay? So for number 7, we like answer choice B because the x's and y's were adding a constant value each time. All right, so B is the correct choice. Number 8, select all the equations that represent a linear function. So the linear functions are going to have an x to the first power. Okay, so or maybe it's just a y equals a number, like y equals 5. So both of those are linear functions. This is the way you're going to see a lot of linear functions in this class with an x to the first power. And then this would be an example of a horizontal linear function. It would just be a horizontal line on a graph. So those are 2 examples of linear functions. So let's pick out all the right choices over here. Y equals 5. Yeah, that's a linear function. It's a constant function. It's going to be a horizontal line. We'll talk more about that next week. Y equals 2x cubed. Well, that cube there, it has an exponent of 3, so that's not going to be a linear function. No, we call that a cubic. That's not important to you now, but that's a cubic function. The third one does have an x to the first power, so we like that. That is a linear function, but there's a 5 in the denominator. That's fine. That's not a big deal. In fact, I could rewrite that by pulling out the 5 from the denominator and calling it -1/5 times x plus 2. So yeah, that's very linear. Now this next one, you might be thinking, yeah, it's got an x to the first power, it's got an x to the first power, but those get multiplied by each other. And when you multiply x by x, you do get x squared. So I'm distributing this x into those parentheses, and I would get x squared minus 2x equals y. And because it has an x squared, that's not linear. No, we call that quadratic. Again, not super important to you right now, but we call that quadratic. So that fourth choice was not linear. Now this fifth choice down here, x to the first power, I like that. This has another x to the first power. So, but it's okay because I'm not multiplying them together. Okay, so in this guy, the one above, I multiplied the x's, and that's why it got x squared. These x's aren't being multiplied by each other. There's nothing there telling me to multiply them, so it's still a linear function. Kind of a tricky one, but still linear. And this last one, yeah, x to the first power, looks linear to me. Cool. All right, guys, so basically we had to watch out for our horizontal lines and our linear functions that had x to the first power. Those are what we wanted. All right, moving on. Is the domain of the graph discrete or continuous? And an easy way to remember this is discrete starts with the letter D. So discrete will have dots, and continuous doesn't. So discrete dots. All right, continuous will have a line. So because this is a bunch of dots, we would say that this sucker is discrete. Cool. And then part B, it has a line, so we'll say it's continuous. All right. Okay, on this next one, we're working with function notation, which is just a fancy way of talking about inputs and outputs. All right, so I have a function named f here. Hi, f. And f of x is equal to negative x plus 6. Find f when x is equal to negative 3. So see how it's in the parentheses? So we're using negative 3 as our input. So what I'm going to do is I'm going to take this f function, and like it looks here, I'm going to switch out that x by x, and I'm going to be replacing x with negative 3. That's my new input. So f of negative 3 is going to equal, and anywhere I saw that x, I'm going to replace that with negative 3. So you saw that x did have a negative in front of it already. Okay, it had a negative in front of it to begin with. So when I do this, I've got negative 3. So negative makes positive 3 plus 6, positive 3 plus 6 equals 9. So I could say that f of negative 3 equals 9, which means that the f function, when it has an input of negative 3, is going to equal 9. Cool. So f of negative 3 equals 9. All right, the next one says f of 20. So that means I have an input of 20. Okay, so f of x equals 5/2 times x minus 15. And I'm going to have an input of 20. So I'm going to replace x with 20. So f of 20 equals 5/2 times 20 minus 15. So anywhere where I had x's, I replaced it with 20. So when the f function has an input of 20, it equals, now when I do the math here, I'm doing 5 times 20. 5 times 20 is 100, and I'm dividing by 2. 100 divided by 2 is 50. Minus 15 makes 35. So I could say that f of 20 equals 35, which means when the f function has an input of 20, the output is 35. So f of 20 equals 35. All right, this question's similar to the one you saw on your quiz, but this one asks for the range. All right, so the one on our quiz told us we could have a maximum of 6 people in the car. So our domain was less than 6 people, 6 people or less. So if I talked about the domain of this problem, how many people can I fit in my car? I can fit between 0 and 6 people in my car. I did 0 because you're not going to have negative people. That wouldn't make sense. So my domain for this problem would be 0 to 6. So those are the x values I could use. So when I do my range, which is how much will I have to pay at the movie theater, well, I would see, okay, what am I going to pay if I don't bring anybody to the movie theater? Well, 9 times 0 is 0. So I could pay as low as $0. But if I fill up my car with all 6 people that can fit in it, that would cost me 9 times 6. That would cost me $54. So my range will be between 0 and $54. And I put the or equal to sign here because it could cost exactly $54. So it could cost me 54. It could cost me that much, that much, that much. Actually, no, it couldn't cost me $30. In fact, this is a discrete function, not continuous. I messed up. My domain isn't 0, all the numbers between 0 and 6, because I can't have half a person. I can't have a quarter of a person. I mean, I guess I could, but I would probably get arrested. So I need to rethink my domain. Because I'm not going to bring half people to the movie theater, I need to write my domain as the set of all x's, where x is between, or that includes 0, 1, 2, 3, 4, 5, and 6. So I've actually got to list those out because we can't bring half people to the theater. That means my range is going to be how much would it cost for 0 people? How much would it cost for 1 person, 2 people, 3 people, 4 times 9, 36, 5 people, 45, and 6 people, 54. So when I do my range, it's how much am I paying for each of those people? So I've got to get rid of $30 because there's no $30 in my range. So there was a 0, there was a 9, a 27, and a 54, but there's no way that I'm going to pay $30. All right. So that's the difference there between discrete and continuous. Okay, so I need to cross this out. That was wrong, and that was wrong. All right, last up here, 2 arcades, and we're playing 16 games. So if I go to arcade A and play 16 games, okay, which is X, then I'm finding out what f of 16 is. How much will it cost to play 16 games? So it's 0.40 times 16 plus 6. 0.4 times 16, 0.4 times 16 is 64. So $6.40. Is that right? Yeah, I hope that's right. And 6, add those together, $12.40. So it's going to cost me $12.46 to play 16 games at Arcade A. That's what that notation tells me. To play 16 games, it's going to cost $12.40. And I found that by replacing X with 16. Boop. Now over here at Arcade B, I know for 0 games, it's $3. 4 games, $6. 8 games, $9. 12 games, $12. So I don't have 16 here. But if I keep the pattern going, where I'm increasing by 4 each time, then the next one would be 16 games, which is kind of what I'm looking for. That means the cost, which is increasing by $3, $3, $3, it's going to increase by $3 more, it's going to cost me $15. So this one asks for the higher cost. The higher cost would be at Arcade B. At Arcade B, it's going to cost me $15 to play games. So which arcade has the higher total cost? Arcade B. And it's going to cost us $15.